Imco is a commercial manager, sustainability lead at Endurans, and today he's going to talk on shining bright, reliable, and sustainable backsheets for high performance modules. Imco, the floor is yours.
Yeah, thank you. Oh, I cannot share yet.
Now I think you can. Just check.
Okay. Can you see the slide?
Not yet.
Not yet. Okay. This should be okay now?
Absolutely.
Yeah?
Yeah.
Okay, thanks. Well, good morning and good afternoon, everyone. I think we had a couple of very interesting presentations, often also touching on the topic of glass backsheet or glass. And yeah, hopefully this presentation will also shed some light there. And I think I will also try to shed some light on how the features of reliability and also sustainability can be integrated in our backsheet products. So for let me go to the next one. For those who are not familiar with Endurance Solar, just a short introduction. We started back in 2011 in the PV market as part of DSM, a large global life science and material science company. In 2015, we started our backsheet activities. And 2 years ago, 2021, we were divested by DSM. And our new owner became Wharton, which is a specialty film and adhesive company based in the US, but also globally active. And at the beginning of this year, we got a co-owner, a capital investor, Riverbend, and with their finance, we will continue our growth. At the moment, we have two business lines. One is the polyolefin-based backsheets, which I will address in this presentation. And the other one is the conductive backsheet, especially designed for back contacted cells, MWT or IBC, to get high aesthetic value modules and also high efficiency modules. Let's go to the topic of reliability and sustainability, and let's first look at the challenges, and then especially, of course, for the industry. And I also took the liberty to apply a third challenge, which is the supply chain, because that is in the current market situation also an important challenge. But yeah, first let's face the market reality. It was already mentioned a couple of times. There's fierce price pressure. We have seen, I think everyone knows this graph on the left side. We have seen enormous cost reduction on the module side. That also has had its impact on the components like backsheets, but also cells for every component. But whereas for instance, the module or the cells have advanced by innovation, increasing their efficiency, for instance, in the backsheet industry, not so much has happened to reduce the cost in sense of innovation. The stack of material and the material used has stayed the same for well, I would say about 40 years now, and you see it in the right graph in the insert. It's a 3-layer stack with 3 films which are adhered together by 2 adhesive films. The core layer is a PET, a polyester, which is relatively cheap and a good electrical insulation, but it's not very suitable for outdoor applications. So as soon as it smells water, it starts to deteriorate. And that means that you either need to stabilize it with stabilization packages heavily, and or you put a protective outdoor weatherable layer, which is in this case the fluoropolymer layer, at the outside to protect the weaker PET core layer. And what has happened to follow the cost down curve, say 2010 or 2005, backsheets were sold at $5, $6, $7 per square meter, and today we are at just above $1 per square meter. And what has happened is that they just reduced the cost of their material by decreasing this protective layer on the outside. I don't know about the inside, about the PET stabilization, but what was visible at least is that the outer protective fluoropolymer layer has been changing, and it started a long time ago with the traditional PVF or Tedlar films on both sides, 38 micron, then gradually 5 micron, then they said we just leave out the inner Tedlar film. Then PVDF came into this industry. We diluted that one with a lot of acrylics, so to reuse the fluoropolymers further. And then at the end, we even said we don't use any protective films anymore. We just put a coating on it, which used to be something like 18 or 15 microns. And today we see something below even 10 micron on in the industry. So what I would call an innovation, it's just a reduction in your most expensive material, and that really compromises the quality. And DuPont has provided some insights there, but there are many more sources. This is the example where DuPont indicated a couple of years ago that almost 60% of failures in the field are related to backsheet failure. But on the other hand, we also see, and we discussed that before in the presentations, that we also are raising the bar. So requirements for backsheets are growing. So especially with the TOPCon and the heterodyne cells, the water barrier, for instance, needs to be much better, much higher than it has used to be. That's one challenge, and the other one on the sustainability front. Yeah, I would say, I mean, sustainability has so many dimensions, and I think for us personally, and which is also steering our developments, the waste issue, which is not there yet, but it will come after 2030, is one of the biggest challenges we have. There's no solution yet. There's a lot of work being done. But you can imagine with all those modules installed on the world, there's a lot of value in these modules, and somehow we need to get that value out. So we need to become more circular, and that is a big challenge, not only for backsheet, but as I'm talking about backsheets, I will just give the example for the backsheet where we are today. We are in a completely linear mode. So we use consume our feedstock, the fossil fuels, and at the end they up on the landfill, or we incinerate that in Europe because you cannot landfill. And that is a costly business and also far from circular or sustainable. And we need to find solutions for that. Last, the supply chain. Yeah, if you look at this is a graph from I think the TaiyangNews report from 2 years ago. If you see where backsheets are being produced, it's mostly by Chinese companies, about 85% at this moment. That makes it a very insecure situation, and we have seen that from COVID period. But on the other hand, we also see that in the other countries like US or India, we see trade barriers coming. There is 30% import tax. There is tax also on fluorinated polymers in India. And we see also barriers coming up with respect to fluorinated backsheets. And this is happening in countries outside of these 85%. So that means that countries like US, India, and Europe, they will have difficulties to get their backsheets. Yes, let's leave it like that on the supply chain challenge. So it's time to change, and that's where I would like to present our solution, because I think that touch upon a large number of these challenges presented. Just to show the concept of our polyolefin-based backsheet, we replaced PET by a polyolefin, and we didn't use elimination, so no adhesives. We have a one-step production process where we bring still 3 layers with 3 different functionalities together in the melt, due to which you get a very good interlayer adhesion. So by combining the right material choice and the right manufacturing process, we intrinsically get or design a backsheet to last. That appears in the resistance, abrasion resistance, and acid resistance, but also especially in resistance against hydrolysis, and also against UV light. And something we touched upon in the previous presentation on acetic acid, due to the choice for polyolefin material, we have a higher water barrier compared to PET-based backsheets. And on the other hand, our permeability for acetic acid is also much higher compared to PET. So that gives you a kind of breathing functionality where water cannot come in, but acetic acid can easily go out. So that's a very important feature of the backsheet. The co-extrusion process gives you, like I mentioned already, a great interlayer adhesion. Now that is conceptual or theory, I would say, but we are already active in the market for quite some years. We have 8 years and many gigawatts of field proof without any failure, which is extremely important to show the bankability of your product, and especially if you go into utility scale, that is a very. We also did a lot of how do you say, accelerated testing. Just the PFOL sequence was mentioned, which we followed, but we also recently finished a benchmarking study in which we look beyond this EEC or cost benchmarking. We went a step further, and we tried to simulate the lifetime energy yield, and also calculated the carbon footprint depending on which backsheet you are using. And see here the type of backsheets which were included in the benchmark study. We also took an experimental grade from us for bifacial modules, and also glass was included. And we used the accelerated testing to an input for the simulation model, and from that degradation rates were calculated, and lifetime energy yield could be calculated, and then with the carbon footprint calculation, you can at the end calculate how many CO2 you are emitting per megawatt hour produced over the lifetime. So, if you want to know more about the results, in the previous slide you saw the QR codes, and find some references related to this study, and also probably next week somewhere you'll be able to download this presentation from our website. Just one slide on the performance, where we really differ from the polyester based backsheets, and that has everything to do with moisture, with humid environments, because of the hydrolysis resistance of polyolefins in general. We make a big difference with the polyester-based backsheets. And in fact, we talked a lot about glass or glass backsheet, and in the left graph you see damp heat. You see the power retention of mini modules after an X number of hours in the damp heat, so a humid environment and high temperature. And there you see that with the green line compared to the yellow line. So the green line is the HPO, the yellow line is the glass that we kind of mimic, or even a bit higher, a bit more stable compared to a glass configuration, and significantly higher compared to the fluoro-based polymers. So this is where you especially see in these humid environments, it's where you see the advantage of using polyolefin based backsheets. And on the right side, you see the results from the simulation. And then especially in these extreme climatic environments, hot and humid, you see the difference between the Then on the sustainability, that was also included in that study. On the right side, you will see the carbon emission per megawatt hour produced over the lifetime, cradle to cradle, and for two situations. One is end-of-life treatment by incineration, and there the difference is still not big. You see some difference because incinerating fluoropolymers, for instance, gives you quite some carbon emission or greenhouse gas emissions. But the big difference really appears as soon as we start applying pyrolysis as an end-of-life treatment. And with that end-of-life treatment, pyrolysis is a process which, especially for polyolefins, is gaining traction. Is really in the scale-up phase at the moment, although everywhere in the world pilot plants are being built. And with that treatment, because of the full polyolefin stack we have, you can, with a yield of 90%, really close the loop. So you can pyrolyze, you can break down the polyolefin in our backsheet to its monomers again, and that can be used to produce in polymer. And by that, in that way, you almost get a net zero product. Flows on the supply chain. We also produce in China. Instead of only producing in China, we start to refocus a bit to a more local for local situation. And especially at this moment, we put our efforts in setting up, or we already have production in US, but we're going to expand it next year to create a good market in the US and service all the growing number of module manufacturers coming up in the US. Greatly helped, of course, by the IRA regulations. But it also matches. So it's, I mean, the logistics, of course, the lead times, it's much shorter and better compared to supplying US from a China base. This is the last slide, just to show you what we have in the pipeline, because based on the HPO technology platform, I would say, we're also developing, and for all three, we are in a scale-up phase, so we should be commercial next year. We're working on a couple of products, so one for bifacial modules. We are also scaling up encapsulant based on co-extrusion technology, and we are also scaling up encapsulant, which is especially matches the conductive backsheet application we have. So in conclusion, we try to meet the challenges in the backsheet industry by designing and providing a backsheet which matches glass-like protection. The design, which is when pyrolysis and module recycling is growing, can reach net zero carbon emission. And we are also focusing on a local for local supply situation. That's it. Any questions, please let me know.
Okay, thanks, Imco. There was really interesting presentation. So can you say where are you in terms of recyclability of the backsheet? So are you already started working, or when do you have plan for a backsheet product that's already that can use the recycled material?
Yes, well, what we do at this moment is more in the circle you saw at the production stage, that we also have a recycling loop. So normally if you produce your backsheet, you just slit away the outer 2 or 3 centimeters at both sides. And that material we can reuse again, because you can remelt our backsheet. It's a monomaterial like structure. So we regrind, remelt, and we feed it back into our extruder. So that part of the recycling we can control and we do ourselves. On the end of life of a module stage, that is more conceptual. We are doing some trials with partners where we check whether you can delaminate or grind away the backsheet so that you get the pure HPO backsheet, and then the whole pyrolysis process can start. So there, it's not even in a pilot scale, or so that's really on a conceptual stage, and yeah, we just following up on especially the pyrolysis industry, which is growing at the moment.
So the in-house recycling, so the edge trims which you are recycling, so this is endless loops, or is there any limit for the recycling amount, number of cycles?
Well, we didn't find it yet. You can make a loops. Of course, we did that in our laboratory, and I'm not sure exactly how often we did this, but I think we can go, or we tested at least for 5 times, and because the amount is very very little, which you have to add to the feedstock, that you will not notice significant differences. Also because the stacks are very similar, and so they do have different functionalities just by tweaking something in the formulation, but sometimes it's only in the stabilization package and even not in the architecture of the polymer. So that makes it quite a robust recycling process.
Okay, I think there are a few more questions in the chat window. It would be nice if you can stay and answer these questions till we meet again for the panel.